Welcome to the cockpit. Strap in because today's explainer is going to cover one of the absolute most critical and honestly most rewarding phases of flying. We're talking about safely bringing your aircraft down from the sky and putting the rubber exactly where you want it on the runway. We are going to master the mechanics of descents to an aim point.
It's the ultimate question, isn't it? How do you actually land a plane exactly where you want it? I want you to think of the descent not just as a routine maneuver, but as a dynamic, real-time physics problem that you and I are going to solve together today. It takes a real blend of mental math, sharp visual cues, and tactile awareness.
Okay, let's dive into this. For today's lesson, our pre-flight briefing looks like this. First, planning your initial descent. Then, mastering the aim point. Next, nailing your glide path, followed by airspeed and power control, and finally we'll wrap up with the art of airmanship.
Starting off with Section 1, Planning Descent, the initial approach to land.
Let's start with the big picture. When you're way up at cruise altitude, how do you even initiate that journey back down to Earth? Well, this requires macro-level planning, long before you ever get near the runway. Because the moment you introduce a ground reference, you've got to account for wind and all of its fun little variations. To arrive over a geographic feature at a specific altitude, you basically have two techniques. The first is the set rate technique. This one's highly calculated. You plan a set rate of descent, let's say 500 feet per minute, you figure out how much altitude you need to lose, and you use your ground speed to pinpoint exactly how many miles out you need to begin the descent. The alternative is the pitch-down technique. This one is a bit more visual. Somewhere between 10 and 20 nautical miles out, you just lower the nose to aim about 3 nautical miles beyond the airfield. This establishes roughly an 18-to-1 descent path. And once established, you simply adjust your power to keep your airspeed in check.
But listen, timing is absolutely everything here. If we leave this initial descent too late, we put ourselves in a really tough spot. We're going to have to drastically reduce power, accept a much higher rate of descent, or be forced to fly a far less direct path just to safely lose that altitude. You always have to be planning ahead.
Moving right along to Section 2, Mastering the Aim Point, the visual reference.
Once we've handled that macro descent, we need to shift our focus to the micro-level visual cues. And this brings us to the single most important aspect of judging a visual approach, the aim point. By definition, the aim point is where the aircraft would physically impact the ground if there was absolutely no correction to its flight path. As you look out the window, it's that singular, fixed point in the windshield that remains completely stationary. Meanwhile, all the other points on the ground appear to just radiate outward from it. Recognizing this really subtle radiating pattern is crucial because it literally tells you exactly where your aircraft is heading.
And getting a good look from the pilot's seat brilliantly illustrates this concept. Notice how, as long as a constant nose attitude is maintained, that crosshair on the runway threshold doesn't move up or down in the windshield at all. As a pilot, your judgment is just a continuous comparison. Where's the aircraft heading to impact versus where do I actually want it to impact?
All right, Section 3, Nailing your glide path, optimal approach angles.
Finding the aim point is step 1. But we also have to approach it at the correct angle. We obviously don't want to drop out of the sky in a 10-degree dive. We need an optimal 3 to 4 degree approach angle. That specific angle allows for proper speed control, safe terrain clearance, and eventually a nice gentle flare over the runway. So the key is breaking this controlled descent down into manageable steps. Step 1, align with the extended center line of the runway. Here's a pro tip for you. If the center line is completely vertical in your view relative to the horizon, you are perfectly on the center line, regardless of where the nose happens to be pointing to fight a crosswind. Step 2, establish that 3 to 4 degree approach angle to your aim point. And step 3, maintain those visual references while simultaneously controlling your airspeed.
Now you might be wondering, how on earth do I know it's 3 degrees without pulling out a protractor? Well, you use a multiplicity of cues, the shape and aspect ratio of the runway, the texture of the ground, and how far below the horizon the aim point sits. But ultimately, with experience, a good approach just becomes a trained instinct. It becomes what aviators call PLAR. That looks about right. You'll just feel it.
Which brings us to Section 4, Airspeed and Power, Managing Aircraft Energy.
We've talked a lot about what things look like outside the window. Let's transition from those visual cues to your instruments and the tactile feel of the aircraft itself so we can properly manage the plane's energy. Now, what's absolutely crucial here is exactly where your eyes should be dancing on the dashboard when they aren't looking outside. You control your flight path with the elevator, but you sustain your airspeed with power. Your scan should continuously loop between the airspeed indicator, the attitude indicator, the altimeter, your vertical speed, and your RPMs.
When checking that airspeed indicator, you're actually hunting for two distinct pieces of information. First, the absolute actual airspeed compared to the manual's required approach speed. Second, and honestly just as important, the airspeed trend. Is it steady? Is it slowly decaying? Or is it rapidly increasing? The trend dictates your reaction. If you're slow and the speed is actively decaying, you need a quick, significant adjustment to thrust and attitude. But if you're just slightly slow, yet the speed is perfectly stable, only a moderate tweak is going to be needed.
But hey, it's not all visual, right? I love this line straight from the flight manual. Your butt will sense this acceleration before the flight path changes or the instruments respond. It is so true. You have to be super sensitive to vertical acceleration. If you feel sudden lift or sink right in the seat of your pants, make an immediate correction to your attitude and thrust. Make the adjustment as soon as the error is seen, felt, or even anticipated.
And finally, Section 5, the art of airmanship, safety and anticipation. Let's wrap up with our last section. Because look, being a pilot isn't just about yanking levers and doing mental math, it's about the broader responsibilities you hold when you are in command of an aircraft. These are the golden rules of airmanship during a descent. You must enter your descents gently. Warn your passengers before you do, because sudden drops can be pretty alarming to someone not expecting them. Anticipate your power, airspeed, and descent profile ahead of time. Keep your eyes outside checking for traffic, and mechanically do not suddenly shock the engine with a massive, rapid power reduction. Smooth, anticipated corrections are the true hallmark of a pro.
When you put the whole shebang together, when you have a stabilized approach path perfectly on the center line, your wind drift is smoothly corrected, your aircraft is properly configured, and your airspeed is precisely locked in, that is when the magic happens. A stabilized approach directly leads to a consistently great landing. It's the most rewarding experience in the cockpit and the truest measure of a pilot's skill and judgment.
So, what does this all mean? We've covered the math of the initial descent, the optical illusion of the aim point, the finesse of the glide path, and the seat-of-the-pants feel of airspeed control. You've got the theory down, pilot. The sky is waiting. Are you ready to take the controls?